Hello friends, in this module we'll look at the introduction about bioinorganic chemistry. The module will follow metals in biology, macro and micronutrients, distribution of elements in biosphere, bioavailability and biostability, metallobiomolecules, and biological role of metals. Now we know that in biology there are many essential elements which are required for the proper functioning. Most of these elements the, are in bulk. For example, hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, chlorine. Now, besides this, there are metals that are also required and are very vital and essential for these organisms. Some of these bulk metal ion nutrients are sodium, magnesium, potassium, and calcium. Besides these, there are also certain metals that are required in small traces or what we call as the micronutrients. For example, the transition metals like vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and molybdenum, all these are called as micronutrients. They are required for the proper functioning in the biological system, but the amount that is required is in trace amounts or in very small amounts. So besides these, there are also non-metals like boron, fluorine, silicon, selenium, iodine, and which comes under this category of micronutrients. Now we see that certain elements are being selected for use in biological systems. Now why is that so? Some of the reasons we can think of is maybe due to their natural abundance. That is, the availability in the Earth's crust or oceans is much higher as compared to the other elements. Another reason we can say is the basic fitness. That is because of the intrinsic chemical suitability. That is, they can readily fit into the biological systems. One more reason can be that is their evolutionary adaptation to realize critically required specificity. We know that in certain biological systems, a metal is required in a certain specific manner or in a particular oxidation state. Certain reactions occur in biology, maybe oxidation or reduction, wherein the metal has to be able to easily change its oxidation state. So this evolutionary adaptation is quite vital for its selection in the biological system. So nature has selected certain elements preferably over the others. If we look at the distribution of the elements as they occur in the biology, we find that some of the elements are required in bulk amounts, like I've already mentioned, and some of them are required in smaller quantities or in trace amounts. Nevertheless, they are also very important or essential for the proper functioning. You see that the elements that are circled, they are the bulk biological elements. For example, sodium, potassium, magnesium, calcium. We know that they play a major role in the biology. Now, besides this, we have these transition elements which are also essential, like for example, manganese, iron, cobalt, nickel, copper, zinc. But the quantity that is required is less. Nevertheless, they are also quite essential. And we also have the non-metals, carbon, nitrogen, oxygen, fluorine, chlorine, phosphorus, sulfur, and so on. So looking at this periodic table, we can see which are the elements that are required in bulk amounts and which are the elements that are required in trace amounts. But all of these elements which are marked are essential elements. Now let us see some of the indicators of biologically important elements. Now, how does a element show its significance or vitality? One is by the relative abundance of these inorganic elements in the earth's crust and in seawater. Another indicator is